Alright, what's up guys? In this video we're going to pick up with some linear algebra, and I'm going to teach you guys how to find the minors and cofactors of a given matrix. So here we have this matrix of order 3. It's a 3 by 3 matrix with 3 rows and 3 columns. We want to find the minors and cofactors of this matrix, which is denoted matrix A. So I think I've done this before, showed you guys how to find the minors and cofactors before. But it's been a while, so I'll do another example. So since we have a matrix of order 3, that means that we're going to have 9 minors, and every cofactor has a every minor has a corresponding cofactor, so that also means that we're going to have 9 cofactors. And so what you need to remember for the minors, remember the minors, that's going to be m sub ij, where I denotes the row and j denotes the column. So the first thing we need to do is find m sub 1 1. Okay, and that's basically going to be us eliminating the first column and first row, and what's left uncovered, so to speak, is what we take essentially the determinant of, and that'll give us the minor. So m sub 1 1 in this case. All right, so that's going to be 6, 7, 8, 9. Now in this particular example, notice that we all have all positive numbers, but as I mentioned in the last video that I did on this, don't expect that to always be the case. Sometimes negative numbers can be plugged into matrices, and it's not that negative numbers are something that's difficult. It's just that students tend, and including myself, make more mistakes with sign changes and arithmetic related mistakes when there's a bunch of negatives in there. In this particular case, we don't have that problem, but just be aware of that. Alright, so the first thing we need to do is we need to do 6 times 9, which we know is 54, and 7 times 8 is 56. So this would be 54 minus 56, which is negative 2. So that's the minor m sub 1 1. We now need m sub 1 2. So for m sub 1 2, well, that's just going to be 4, 7, 7, and 9. So 4 times 9 is 36, 7 times 7 is 49, so that's going to be 36 minus 49, which is negative 13. We now need m sub 1 3. Perhaps that one's a little bigger than the other two. Sorry about that, so let me see if I can correct it a little bit. There you go, make it look a little better. Alright, so now we need m sub 1 3. Again, keep in mind that I denotes the row, j denotes the column. That's how you tell. And so in this case, we'll have 4, 6, 7, and 8. So 4 times 8 is 32. 6 times 7 is 42. So that's going to be 32 minus 42, which is negative 6. So now we move on to m sub 2 1. So for m sub 2 1, well, that's just going to be 2, 3, 8, and 9. So 2 times 9, that's 18. We'll have 3 times 8, which is 24. So we'll have 18 minus 24, which is negative 10. Or excuse me, negative, not negative 10, excuse me, negative 6. Excuse me, sorry about that. No, this is negative 10, sorry. Okay, so now we have matrix 1 3, we have or minor 1 1 1 2 1 3. That's negative 10. Sorry about the arithmetic related mistake over there. And then for m sub 2 1, we got 18 minus 24. That's negative 6. So sorry about that arithmetic related mistake. So now we need m sub 2 2, and we really approach this no different than we approach the other two. So for m sub 2 2, well, it's just going to be 1 3 7 and 9. So it's going to be 9 minus 21. 9 minus 21 is negative 12. So we get negative 12. And if you notice here, we're getting all our minors, but again, since it's a matrix of order 3, we have 9 minors. So now we need m sub 2, 3. That's what we need. Alright, so for m sub 2, 3, what's 1, 2, 7, and 8? I'm just looking at our matrix here. So it looks like we'll get 8 minus 14, which is negative 6. Hopefully you guys can still see. Try to adjust the lighting. Okay. Alright, so we now move on to m sub 3, 1. So for m sub 3, 1, we move on to that one next. And if we look at our matrix, I'm going to have to pull it out because I need to see the matrix. So what I'm going to do is I'm going to kind of angle it that way. Okay. Alright, yeah, that's better. Alright, so m sub 3, 1. Okay, so that's going to be 2, 3, 6, and 7. So that's 14 minus 18, which is negative 4. We now need m sub 3, 2. So we'll look at our matrix, m sub 3, 2. That'll be 1, 3, 4, and 7. So it's going to be 7 minus 12, which is negative 5. And let's get the last minor here. So we need m sub 3, 3. So look at our matrix. M sub 3, 3. That's going to be 1, 2, 4, and 6. So that's going to be 6 minus 8, which is negative 2. So now we have all of the minors of the matrix. And every minor has a corresponding cofactor, so we'll need to find the cofactors next. So those are your minors. Okay. Sorry about that arithmetic related mistake up there earlier. Just shows you how you got to be a little careful, you know, when you're doing the arithmetic. Okay, alright, so that takes care of the minors. Now on to the cofactors. So we need those now. Okay. Alright, so for the cofactors, remember that c sub ij is equal to negative 1 raised to the I plus j, where again I is the row, j is the column, or denotes the row and denotes the column, multiplied by m sub ij, which of course is just the minor. Okay. So finding the cofactors is actually not that hard at all. Again, the bigger the matrix is, the more work it's going to be. I guess I could just say that. Okay, so one thing I do want to quickly talk about prior to starting, because this is very important. Remember, let's say I take a negative 1 and I square it. Well, we know if we square a negative number, we get a positive number. Okay? However, if I take a negative number and I cube it, I get negative 1. Remember that if you're raising a negative number to an odd power, it stays negative. If I'm raising a negative number to a even power, which 2 is obviously even, then it gives me a positive number. The reason why I wanted to bring that up is because that is a quick way to make a mistake. A lot of students, believe it or not, a lot of students don't know that. They will easily write negative 1 cubed down as positive 1. So just a general reminder about that. Again, it may sound ridiculous, but I'm telling you, a lot of students honestly forget that. So I just want to point that out, because you can easily make a mistake finding the cofactors if you don't keep that in mind. Okay, So let's go ahead and get started with the cofactors here. So we know every minor has a corresponding cofactor, so let's begin. So we got c sub 1, 1, and that's going to be equal to negative 1 raised to the 1 plus 1. And that's going to be multiplied by, if we go back to, I'm going to have to pull the stuff out. Actually, I'm going to have to put it right here because so I can see. So it's going to be multiplied by our minor, remember, which was 6, 7, 8, and 9. When we took the determinant, and remember we got negative 2 when we did that. So here for c sub 1, 1, we'll have negative 1 raised to the 1 plus 1, but we do have to multiply by negative 2. So that's going to be positive 1 multiplied by negative 2, thus giving us a negative 2. So that's the cofactor for that one. Okay, so make sure you go slowly with this. So now we move on to c sub 1, 2. And again, use the same formula. It's just going to be negative 1 raised to the 1 plus 2. And again, I'm not going to write the matrix. I'm just going to write I just wanted you to kind of see how it works. The m sub ij, that just denotes the matrix. So I'm actually not going to draw the matrix again. You're just going to take your minor, which for m sub 1, 2 was negative 13, remember? So that would be negative 13. Now, notice here that we have negative 1 being raised to an odd power because 1 plus 2 is 3. So that's negative 1 raised to the third power, which is negative 1, but I'm multiplying it by negative 13. Thus gives me a positive 13. Okay, so very, very easy to make a mistake there. So take your time on this. And we'll keep going with it because we know we need 9 cofactors since we had 9 minors. So we'll have negative 1, and this is going to be raised to the 1 plus 3. So we are raising 4 is even. So we are raising this negative number to an even power, which means we're going to get a positive number. And then our minor was negative 10 for that, remember? So what that means is negative 10 is the cofactor for m sub 1, 3. Alright, let's continue with this. Okay, so I don't know where I'm gonna put it. I guess I'll put it right here because I need to be able to see it. Okay. I gotta find somewhere to sit this. I'll put it right there. I'll just have to look back at it. Okay. Now let's move on to c sub 2, 1. And again, I got to look back at the papers because I don't know what the minors are. Off the top of my head, I got to look back. Okay, so for m sub 2, 1, that's going to be negative 1 raised to the 2 plus 1. Now we multiply by, if we go back to the cofactor, it was negative 6, remember? So this would be negative 6. And so what will we get here? We'll get a positive 6 because again we're raising the negative 1 to an odd power. So if we multiply a negative number and a negative number, we get a positive number. So the cofactor for c sub 2, 1 is positive 6. Let's continue with this. So c sub 2, 2, and hopefully you're seeing that it's actually a relatively straightforward procedure here. It's just very easy to make a mistake sometimes. That's why I always try to go as slow as possible. And we just got to multiply that by negative 12, since that's what our minor was. So again, we have this negative 1 here being raised to an even power. 4 is even. So this just stays negative 12. That's the cofactor. And we got to get 3 more. So c sub 3, 1. So in that case, c sub 3, 1, that's negative 1 raised to the 3 plus 1. And if we go back to our minor for m sub 3, 1, and I got looking at our minors here for what we did earlier. Our minor was negative 4, remember? So it's been negative 4. Let me make sure. Oh, I'm sorry. I'm missing c sub 2, 3. Sorry about that. Yeah, I'm missing c sub 2, 3. So c sub 2, 3, remember, that's just going to be negative 1 raised to the 2 plus 3. Sorry about that. And then remember that our minor was negative 6, so we times negative 6, which is positive 6. Almost forgot that cofactor. Sorry about that. Now we've moved on to this one. So now we got c sub 3, 1. So this negative 1 here is being raised to a even power. Okay. So if we do this, we'll get negative 4 as the cofactor. We need the last two. So we got c sub 3, 2. That's negative 1 raised to the 3 plus 2. And if we go back to our minor for 3 sub, that was negative 5. So of course this gives us positive 5. And then the last cofactor was c sub 3, 3. And that's equal to negative 1 raised to the 3 plus 3. Remember, 6 is even. And our minor for that was negative 2. So the cofactor here is negative 2. So all of our cofactors, we now have all of our cofactors. So these were the first 3 cofactors. Almost left out the c sub 2, 3. Sorry about that. And then these were the last 3 of our cofactors. Okay. And so we now can write our final answer down. And our minors and cofactors that we get for, or that we got, will of course be, the matrix will be of the same order as what we started with, which is a matrix of order 3. So our cofactor matrix is going to be the same size. And if we look at our minors here, excuse me, if we look at our cofactors, so it looks like we're going to have negative 2, positive 13, negative 10. I'm going to have 6, negative 12, a positive 6, a negative 4, a positive 5, and a negative 2. So that is going to be the minors and cofactors of matrix A. Alright, so hopefully you were able to see how it was done, and let me circle it again. It's very easy to make a mistake, as I did a little earlier in there. I made a bit of a arithmetic related mistake, so just goes to show you that you got to be a little careful. Obviously the bigger the matrix is, the more work it's going to require, and it's a greater chance of you making a mistake the bigger the matrix is. So just take your time with that. And also, don't be afraid to use a calculator to check your arithmetic. Again, the numbers here weren't too big, but again, it's not uncommon to get an arithmetic related mistake on that. So that's why you want to make sure you're using the calculator, because if you just get one of these minors wrong, then the corresponding cofactor will be wrong as well, obviously. So you'll need to use a calculator. Even if the numbers are small, make sure you're using a calculator for it. So that's linear algebra. That's how you find the minors and cofactors of a matrix. So I will see you guys next time.